Welcome to MRL. In this learning session, we'll be learning the solutions of exercise 2.1 of 9th standard Polynomials chapter. That is the textbook 25-26 textbook, which is now being used or introduced by the state boards only and not by the CBSE board. Now in the first question here, we have to identify the polynomials in one variable. Now if you look at this polynomial, 4x square minus 3x plus 7 is a polynomial in variable x. This is a polynomial because all the powers are positive integers and the variable is only one variable, that is x. Now if you look at the second polynomial, y square plus root 2, again it is a polynomial of power is again a positive integer, and it's also in one variable y. The third example, 3 root t plus t root 2 is not a polynomial because root t is t raised to half, which is not a whole number or a positive integer, therefore it is not a polynomial. Now y plus 2 by y. 2 by y is y raised to minus 1. That means it is y plus 2 into y raised to minus 1. It is not a polynomial because the power is a negative integer. Now x raised to 10 plus y raised to 3 plus t raised to 50 is polynomial, alright, but not in one variable. There are multiple variables x, y and t. So that is how we identify the polynomials in one variable. Now to write the coefficient of x square in this, in the first example 2 plus x square plus x, the coefficient of x square is 1. In the second example, the coefficient of x square is minus 1. And in the third example, the coefficient of x square is pi by 2. The fourth example, root 2x minus 1, the coefficient of x square is 0 because there is no coefficient of x square here. Therefore, the coefficient of x square is 0. Now to give one example of a binomial of degree 35 and of a monomial of degree 100. 3x raised to 35 minus 7, the power is 35, the degree is 35, and therefore there are two terms here, therefore it is a binomial, and the power is 35, therefore it is a binomial of a polynomial which is a binomial of degree 35. 5y raised to 100, the power of y is 100, therefore, and 5y is a monomial, therefore 5y raised to 100 is a monomial, and the power being of y being 100, it's a polynomial of degree, rather monomial of degree 100. Now to write the degree of the polynomials, now the highest power in this polynomial is 3, therefore it is a third degree polynomial. 4 minus y square, the highest power is 2, therefore it is a polynomial of degree 2. 5t minus root 7, the power of t is 1, therefore it is a polynomial of degree 1, or it is a first degree polynomial. Now 3 can be written as 3 into x raised to 0, it is a polynomial of degree 0 because the highest power is 0. Classifying the polynomials as linear, quadratic and cubic. Now in this case, x square plus x, because the highest power is 2, it's a quadratic polynomial. Here also highest power is 2, therefore it is a quadratic polynomial. Then r raised to 2 is again a quadratic polynomial because the power is 2. X minus x cube, the highest power is 3 and therefore it is a cubic polynomial. 7x cube, the highest power is 3, therefore it is a cubic polynomial. 1 plus x is power is 1, x is having a power of 1, therefore it is a linear polynomial. 3t, the power of t is also 1, therefore it is a linear polynomial. Now coming to the exercise 2.2 of the polynomials chapter of 9th NCERT state syllabus. Now to find the value of polynomial p of x, 5x minus 4x square plus 3, it is given to us. Now we have to find the value of the polynomial p of x when x is equal to 0. Therefore wherever x is there, put 0. So it will be 5 into 0 minus 4 into 0 square plus 3. That will be 5 into 0 is 0 and this 0, therefore the answer is 3. Therefore the value of the polynomial when x is 0 is 3. When x is minus 1, put minus 1 wherever x is there. So 5 into minus 1 minus 4 times minus 1 square plus 3. Then plus into minus is minus 5. Minus into minus 1 square is 1. So minus 1 into minus 4 into plus 1. Therefore minus 4 into 1 and plus 3. So it will be minus 5 minus 4 plus 3 minus 9 plus 3 minus 6 is the answer for the value of the polynomial when x is equal to minus 1. When x is equal to 2, put wherever x is there, put 2. So it will be 5 into 2 minus 4 2 2 square plus 3, 10, 5 to the 10, minus 2 square is 4, 4 for the 16, and plus 3, it will be 13 minus 16, that is minus 3. Therefore, P of 2, that is the value of the polynomial when x is equal to 2 is minus 3. Now coming to the next example, to find P0, P1 and P2 of the given polynomials. We are given a polynomial, first polynomial here, Py, y square minus y plus 1. We have to find P0, that means wherever y they put 0, so 0 square minus 0 plus 1, 0 minus 0 plus 1, therefore P0 is plus 1. And find out P1 now, where y they put 1, so y square minus y plus 1 becomes 1 square minus 1 plus 1, 1 square is 1 minus 1 plus 1, that is 2 minus 1, that is 1. And for P of 2, so P of 2, wherever y they put 2, so it is 2 square minus 2 plus 1, so 4 minus 2 plus 1, 5 minus 2, that is 3. Now coming to the second example, P of t is given as 2 plus t plus 2t square minus t cube. We have to find out P0, wherever t is they put 0, so 2 plus 0 plus 2 0 square minus 0 cube, so 2 plus all the other three numbers are zeros there, and therefore the answer is 2. For P of 1, wherever t they put 1, so it will be 2 plus 1 plus 2 into 1 square minus 1 cube, so 2 plus 1 plus 2 minus 1, 5 minus 1, that is 4. And for P2, wherever t they put 2, to 2 plus 2, 2 into 2 square minus 2 cube, so 2 plus 2, 2 into 4 minus 8, 2 plus 2 plus 8 minus 8, a minus 8 and plus 8 cancels there, the answer is plus 4. Remember that. Now coming to Px is equal to x cube, and we have to find P0, so 0 cube becomes 0. We want to find 1, P1 there, put 1 cube, that is 1. P2, 2 cube is 8. And the last example in that, P of x is equal to x minus 1 into x plus 1. Wherever x is there, put 0, it will be 0 minus 1 into 0 plus 1, so it will be minus 1 into 1 minus 1. And to find P1, wherever x is there, put 1, 1 minus 1, and 1 plus 1, this becomes 0. And P2, 2 minus 1, 2 plus 1, that is 1 into 3, and that is 3. Now the third example is to verify the given values are the zeros of the given polynomial. Now we are given a polynomial P of x is equal to 3x plus 1. We are given a value x is equal to minus 1 by 3. Now we have to find out whether x is equal to minus 1 by 3 is a 0 of this polynomial. If it is 0, then the value of P of x must become 0. That means P of minus 1 by 3 is equal to 3 into minus 1 by 3 plus 1. 3 cancels, minus 1 plus 1 is equal to 0. The value of the polynomial is becomes 0, and therefore x is equal to minus 1 by 3 is the 0 of this polynomial. The meaning is very simple. The definition of 0 of a polynomial is the value of the variable which makes the value of the polynomial 0. Here the value of the polynomial is made 0 by putting x is equal to minus 1 by 3. Therefore x is equal to minus 1 by 3 is the 0 of the given polynomial. Now minus 1 by 3, the second one is find out P of minus 1 by 3, and we find that it is definitely a 0 of the polynomial P of x. Now coming to the next example, P of x is equal to 5x minus pi, put x is equal to 4 by 5. That means we have to find out whether x is equal to 4 by 5 is a 0 or not. So P 4 by 5, 5 cancels 4, therefore 100% it is not a 0. Therefore x is equal to 4 by 5 is not equal to 0, because P of 4 by 5 is not equal to 0. Therefore x is equal to 4 by 5 is not the 0 of the polynomial. Now next one is P of x is equal to x square minus 1. We have to find out whether x is equal to 1 is a 0 and x minus 1 is a 0 or not. Now find out P of 1 first. Wherever x is put 1, 1 square minus 1, so it becomes 0. Therefore x is equal to 1 is the 0 of the polynomial. Take x is equal to minus 1 here. P of minus 1 is minus 1 square minus 1, that is 1 minus 1 again, 0. Therefore x is equal to minus 1 is also the 0 of the given polynomial. The next example is P of x is equal to x plus 1 into x minus 2. We have to find out whether x is equal to minus 1 is a 0 or not, and x is equal to 2 is a 0 or not. Now to find out, put x is equal to minus 1 in that is in the given polynomial, then it becomes minus 1 plus 1 minus 1 minus 2, 0 into minus 3 is 0. Therefore P of minus 1 is the 0 of the polynomial. Now find out 2 minus 2 is 0. Again x is equal to 2 is also the 0 of the polynomial, and that is P of x, or P of x is equal to x plus 1 x minus 2 there. Now P of x is equal to x square. Now find out whether x is equal to 0 is a 0 or not. So by putting x equal to 0, it becomes 0 square is 0. Therefore x equal to 0 is the 0 of the given polynomial. Now next one is Px is equal to Lx plus m. X is equal to minus m by L, where x is they put minus m by L, L cancel, minus m plus 1, m becomes 0, and therefore x is equal to minus m by L is definitely the 0 of the polynomial P of x. Now coming to the next example, p of x is equal to 3x square minus 1, and find out whether x is equal to minus 1 by root 3 is a 0 and x is equal to 2 by root 3 is a 0. Now to find out that, put wherever x is there, put minus 1 by root 3. So 3 into minus 1 by root 3 square minus 1. So 3 root 3 square becomes 3 minus 1 square 1 by 3 minus 1, 3 cancels, 1 minus 1 is 0. Therefore x is equal to minus 1 by root 3 is a 0 of the given polynomial p of x. Now for 2 by root 3, wherever x is there, put 2 by root 3. 3 into 2 by root 3 square minus 1, and 2 square is 4, root 3 square is 3, 3 cancels, 4 minus 1 is 3. Therefore p 2 by root 3 is not equal to 0. Therefore x is equal to 2 by root 3 is not the 0 of the given polynomial. Now the next example is p of x is equal to 2x plus 1, and find whether x is equal to half is the 0 of the polynomial. So put x is equal to half in the given polynomial. 2 into half plus 1, that is 2 cancels, 1 plus 1 is equal to 2. Now we find that p of half is not equal to 0. Therefore x is equal to half is not the 0 of the given polynomial. Now the next example is fourth example, that is to find zeros of the polynomials. This is a very simple example. Try to understand this. Now the polynomial given is p of x is equal to x plus 5. We have to find the 0 of this, and to find the 0 we know that we have to equate x plus 5 equal to 0, because if to find the 0, p of x has to be 0, therefore x plus 5 has to be 0. X plus 5 equal to 0, x is equal to minus 5 is the 0 of the given polynomial. Second example, p of x is equal to x minus 5, then equate x minus 5 equal to 0, x is equal to 5 is the 0 of the polynomial, because when I put x is equal to 5 here, 5 minus 5 is equal to 0, px is equal to 0, therefore x is equal to 5 is the 0 of the polynomial. Now the third example, p of x is equal to 2x plus 5, 2x plus 5 equal to 0, 2x is equal to minus 5, x is equal to minus 5 by 2 is the 0 of the given polynomial. The next one is p of x is equal to 3x minus 2, equate 3x minus 2 equal to 3x minus 2 to 0, that is 3x minus 2 equal to 0, 3x is equal to 2, x is equal to 2 by 3 is the 0 of the given polynomial. The next example, p of x is equal to 3x. Now equate 3x to 0, 3x is equal to 0, x is equal to 0 by 3, x is equal to 0 is the 0 of the polynomial. Now p of x is equal to ax, ax is equal to 0, x is equal to 0 by a, and again x is equal to 0 is the 0 of the given polynomial. P of x is equal to cx plus d, cx plus d equal to 0, cx is equal to minus d, or x is equal to minus d by c is the 0 of the given polynomial. Remember, to find the 0, equate the polynomial to 0 and solve the equation. So that means 0 makes the value of the polynomial 0, therefore we have to equate that polynomial to 0, and that is how we find the zeros of the given polynomial. So these were a few examples of the two exercises there, and please learn very simple examples, understand the basics, and learn how to solve them, practice them, note down in a book for your future reference. Thank you.